All right, these are the notes for A-6 and A-8, solving inequalities and distance and midpoint formula. We're going to start off by solving inequalities. What you need to remember for those is if you ever solve an inequality, that you need to switch the direction of the inequality sign if you divide by a negative. There are ways to avoid this, and I'm actually going to avoid it in this first one, and I'll show you what I do to do that. So first off, I want to get rid of the 2 on the bottom of the denominator, so I'm going to go ahead and multiply by 2. Leaving us with 2 minus 3x is greater than or equal to 2x minus 8. So I could take this 2 over to the other side, which would give us a negative 5x, and in the end I would have to divide by a negative. So just, I guess, to avoid that, instead of moving the 2 over to this side, what I'm going to do to keep my x values positive is add 3 to both sides and add 8 to both sides. So this is going to become 10 is greater than or equal to 5x. Now when you divide by 5, you don't have to remember to switch the sign or anything, and you're going to get 2 is greater than or equal to x. I like to rewrite it so that x is on the left side. So visually this is going to be, here's our number line. We're talking about all values that are equal to 2 and less than, so you're going to shade to the left. This next one, the double inequality, if you ever have a double inequality, it's really similar to solving a linear inequality. If you are trying to remove things from x on the inside, not only do you do it to the inside, but you need to do it to both sides of the inequality. So this is going to be negative 2 is less than or equal to 6x, which is less than or equal to, or just less than 4. Then divide by 6. So negative 1/3 is less than or equal to x, which is less than 2/3. This is one of those bounded inequalities, so it's stuck between 2 numbers. You're going to have a closed-in dot on 1/3 and an open dot on 2/3. And shade in between. Okay. When you do absolute values with inequalities, a good way to set this up in every single situation, no matter what way your sign's open, is that you're going to put the absolute value stuff in the middle. You're going to put the given answer to the right, the negative version of that answer to the left, and then in between you're going to use whatever signs that they gave you. So given inequalities. So for that, inside of our absolute values, you have x minus 5. The answer is 2. The negative version of that is negative 2. And the inequality signs that they gave us are those. From here, you can just solve by adding 5 to everything. So you get 3 is less than x, which is less than 5. Or sorry, 7. Again, this is another bounded inequality. Your values are going to be between 3 and 7. You're going to have open dots. And there you go. This other one's a little bit different. You are going to set it up just like I have over here, where the inequality is, or the absolute value is in the middle. The positive version is going to be on the right, the negative version on the left, and then the given signs are going to open up this way. What you can do is add 20 to each side. So this inequality is going to become 16 is greater than or equal to x. And then x is going to be greater than or equal to 24. So that kind of stopped me a little bit. So I'm going to actually go ahead and draw what that looks like. If you were to cover up this 24, you would have x is less than or equal to 16. So here's 16. I'm looking at all the values that are equal to it and then to the left. On the other side, if you were to cover up the 16, we're going to have x is greater than or equal to 24. So here's 24. I'm going to shade that in and shade over to the right. So here you can kind of see that it's both of these, I guess, are unbound, And what you could do, you could keep your inequality written like this, or you could write it like this. X is less than or equal to 16, or X is greater than or equal to 24. This last rational inequality value that we're going to do, what I would say is just make this an equal sign, and then you can cross multiply. So you're going to get 8x plus 12 is equal to x plus 5. Subtract x over, and subtract 12 over, and divide by 7. So you get this value that x is equal to -1, but I don't really know if my values are going to be bigger than or less than that value. So what you can do is test. An easy number to test is 0. So I'm just going to try it. And by trying it, I'm going to plug it in. So I'm going to get 4 over 5. Is that greater than 1 over 3? It is. And since 0 works, I'm going to go ahead and shade to the right of the -1. This actually should be an open dot because our original inequality did not include an equal sign in it. All right. So written as an inequality, that means that x is going to be greater than -1. On the next page, which is actually the next section, we did the distance and midpoint formula. And I know for a fact that you've done distance and midpoint pretty much every year since algebra and every curriculum. So I'm going to kind of breeze through it. Ask me in class and I can maybe get you the distance formula for your calculator. Pretty much as always, what you're going to do is identify x1, y1, x2, y2. And you're just going to plug them into the given equation. So for our distance formula, we're going to have the square root of 6 minus 1 squared plus 0 minus 12 squared. Let's see, 6 minus 1 is 5. If you square that, that's going to give you 25. 12 squared is 144. Add them together, you get 169. And the square root of that is 13. Midpoint. Keep in mind that midpoint is a point, so your final answer will be in point or coordinate form. So for this, you're going to add your x's together, so you're going to get 6 plus 1 over 2, and 0 plus 12 over 2. 7 over 2 is 3.5, and 12 over 2 is 6. You can try this next one on your own. For your distance, you should get, I believe, 15, and the midpoint ends up being -2.5 and 2, right? But you can try it on your own, see if you get the same thing.